Thank you for making time and joining us today.
Absolutely. Thank you for thinking of me.
Yeah, this is going to be awesome. The world is pretty intense right now, so for the next 30 minutes, we're going to give everybody a little bit of a treat and talk about micromachining and all sorts of really interesting projects that you're working on. So, for just to give you people a little bit of context and tee you up, Nick is a watchmaker and the president of the New York Horological Society. I think it was about a year ago that we did a podcast interview, and you had this wonderful description of what it means to be a watchmaker. And so maybe we could start there. So, Nick, what is a watchmaker?
Well, first of all, 99% of watchmakers don't make watches. This is the common misconception. You go to some party, you meet someone, say, "Hey, what do you do?" "I'm a watchmaker." "Oh, can you make me a watch?" Or "What did you make the watch that you're wearing on your wrist?" But 99% of the time, the answer is no.
Yeah.
It's kind of a misnomer in the English language. It's kind of a similar situation to you're a car mechanic, right? Car mechanics, for the most part, don't make cars. Maybe they'll make one or two parts on the car, but really what they do is they fix a car. They analyze it, they see what's going on inside the engine, how it's working, and if it needs to be adjusted, they make the adjustments. They probably understand the overall concepts of how an engine in a car works, but they're not the ones at the factory building the entire engine and the entire car.
Right.
And even if someone does work at a car factory, there's hundreds of people that all do their individual job to put a car together. It's the same thing for watches. Big factories in Switzerland, there's hundreds of people that each do their specific job to make all the parts of a watch, to polish them, to make them look really nice, to put them together, to regulate it, and finally to get to the point where it's something that you can put on your wrist and wear.
So this brings us to the word like horloger, right, which has a different direct translation than the mechanic.
Yeah, I mean, if we were speaking French and you asked me what I do, what my job is, I would say "Je suis un horloger." I am a horologist, and it's kind of a more general term. And I wish that term made its way over to the English language, because it would make things easier for me when I'm at a dinner party or something, and someone tries to ask me to make a watch for them. So horologist, it's more of a general term saying that you work with watches or clocks in some sense. It's kind of like saying you're an athlete. It can mean a lot of different things.
Yeah.
It's just a general term.
Cool. Well, helpful context. We've got a bunch of people who just joined in the last couple minutes, so welcome everyone. Yes, horology sounds so fancy. Use it. I agree. Keep dropping some things in comments, and we'll make sure to cover them. My name is Bantam. I'm here with Bantam Tools. We make this thing, the Bantam Tools Desktop PCB Milling Machine, which I have behind me. And today we're going to be talking about some of the work that Nick has been doing using this machine. So, Nick, last week you posted this awesome image of an escapement mechanism that you had prototyped on the PCB mill. Could you show it as a point of reference for people, and then to sort of take us into to what this part is and how you made it? And
let me flip the camera around here without hanging up. Okay.
Cool.
So those are the two main parts of the escapement. There are two other parts that are a little bit difficult to show because they're even smaller. But for a sense of scale, there's a penny next to them. And then here's a mechanical watch with those two parts in them, and it's running. And I think I can get closer here. I'm going to use my loop, which is a watchmaker's loop here, and I'm just going to hold it up to the phone, and hopefully we're going to get a close up. Let's see.
Ooh.
There we go.
Awesome.
Yeah. So the two parts there. The gear on the left is the escape wheel.
Okay.
And the part on the right is the pallet fork, or otherwise known as the lever, or in German it's the anchor.
Okay.
And there's a lot of terms in watchmaking that are kind of specific to the profession. So in watchmaking, a wheel is what everyone else would call a gear.
Okay.
So an escape wheel, it's like an escape gear, but we call it a wheel. And you can see that the teeth on it have a really interesting shape. It's not like a normal gear teeth. They're specifically shaped to do a kind of a special function to do what the escapement does, which is to translate motion.
Okay.
If that makes sense. I'm going to switch the camera back.
So I'll be the first to admit this is not my bag. Last week we were talking with Eddie Serratos on stomp boxes and audio, and I was much more well prepared to be sympathetic to the things that he was discussing. But I did a little bit of reading beforehand. So this is the escapement mechanism. One of its functions is to sort of keep the springs and all the stored energy in a mechanical watch from just completely exhausting itself initially, or where am I going wrong? Give us some context for what this thing is.
That's definitely a correct explanation. That's one aspect of an escapement. If we did not have an escapement in a watch, you would wind up the watch, and all of the energy that you wound into the spring would just immediately leave.
Okay.
Probably pretty quickly, pretty violently. It could break parts. When we are working on a watch, the first thing that you do is you let down the watch. You take the power out of it, and that's because if you start taking apart a mechanical watch without letting the power out, springs are going to start flying all over the room, and you're going to break parts. So the escapement is one piece that kind of keeps the energy in the watch, and it releases it in very controlled segments. So when you hear you may even be able to hear this watch here through my microphone. You hear the tick, 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 tick.
Yep.
That's the escapement doing its job.
Ticking back and forth as the... And so what's unique about this? This is a dual axis escapement. What's that mean?
So this is a coaxial escapement that I made. The coaxial escapement was popularized and made very famous by George Daniels, who was a very well-known watchmaker. He's probably one of the most famous watchmakers of the modern era. A lot of watchmakers did many inventions and advancements back in the 18th and 19th centuries. And watchmaking kind of got to a point of maturity where it didn't really develop much over the early 20th century. But George Daniels was a British watchmaker, and he was the first person in a long time to invent a new escapement. And so this was an escapement that made a significant contribution. It was an advancement. The basic idea was that it was an escapement that didn't need lubrication. So lubrication is kind of the Achilles heel of mechanical watches. It's just like, we were talking about cars earlier. If you don't put oil in your car, eventually the engine is going to destroy itself. The same thing happens in a mechanical watch. It needs to be lubricated. And the point where lubrication is very, very important is the escapement, because it is doing a lot of things really quickly, and that lubrication will wear out. And if it's not sufficient, the watch is going to stop, and parts are going to get worn down, and it's not good. So it was always kind of the holy grail of watchmaking, if you could find the perfect lubrication, or even better, figure out a way to make a mechanical watch or make an escapement specifically that doesn't need lubrication at all.
Okay.
Yeah.
And
go ahead.
No, go ahead.
But this coaxial is different than George Daniels' coaxial escapement. Sorry, I got ahead of myself. So George Daniels popularized the coaxial, but about 100 years before he did that, there was a watchmaker in New York. His name was Charles Fassolt, and Charles Fassolt also invented a coaxial escapement. Coaxial just means two wheels or two gears that are on the same axis.
Okay.
And so Fassolt's coaxial escapement was similar to George Daniels. George Daniels improved on the concept to a large amount, but the Fassolt escapement is also coaxial. The big distinction is it provides just one impulse per oscillation of the balance wheel.
So some of the videos I was watching online, it's ticking back the mechanism ticking back left and right, and with each tick, as it reaches that finite position, the wheel is advancing one increment. And what you're saying is that this is just incrementing once with every revolution, or
yeah. So in a modern mechanical watch, pretty much any mechanical watch that you buy, so the escapement, what it does is it translates motion. So the gears move in a circle, and the escapement translates that to impulses back and forth. Most escapements do an impulse to the left, impulse to the right, right? So left, right, and that's the tick-tock sound that we hear. But the Fassolt escapement, it makes only one impulse. So
gotcha.
Impulse.
Gotcha.
Yeah.
You're speaking you're speaking about this like you really know the histories, which makes total sense with your with the New York Horological Society. So I feel like we could have a lecture series on the history of watchmaking, which would be
good.
very lengthy.
Yeah. I mean, don't get me started. I'll talk about watches all day. That's kind of my thing.
So let's go back to the machining of this. This is you held it up under the loop, and we're some fraction of the diameter of a penny, and it's quite a thin part. What's it look like to prototype this? Bring us into the experience of prototyping this. And I should say, like, by all means, flip the camera around and or hold things up in front too, sure, as it's helpful, because I think people joining and listening to this would really get a kick out of seeing your desk and your space and the tools that you have.
So this is my desk. I don't have a big workshop or studio. It's because I live in New York. I have a small New York apartment. So this is my workspace here. It's just a desk. And what I use most of the time for my prototyping, these are brass stamping blanks. So I get these on Amazon or eBay. They're really cheap, and they're just very thin brass blanks, 16 millimeter diameter, 0.4 millimeter thick, and I use these for almost all of my machining. So one of them is for one of these parts, and what I do is I use this double-sided tape.
Yep. And
just stick it in the Bantam Tools mill and go to town with it. I've got let's see here. I've got lots of end mills. These are kind of some bigger end mills. This is what I use most of the time. This is pretty much the smallest commercially. I think you can go a little bit smaller, but it gets to a point of diminishing returns where you get so small that they get very expensive and they get to be really, really difficult to work with. So I've kind of settled on the 0.3 millimeter diameter end mill.
It's pretty small.
Just small. It's small enough where if you touch it, it'll break pretty easily.
Yeah.
I'll open one of these up so we can see. Hold on, I'll flip the camera around.
Okay.
And I've developed a few kind of little tricks to get these to work reliably because they're so delicate. Even the process where you measure the height of the end mill.
I was just going to ask you about that, because in the PCB mill, the way that we set the tool heights is it uses the conductive bed, and so you install the tool and it goes down and it locates, it grounds out and locates the bottom of the bed. And it's a
Most of the
gentle
time,
process, but
most of the time it's not a good idea with these end mills. Let's see if I can.
I'm leaning into the screen as if that's going to help.
Here, I'll flip it around again so you can see how small this is. They're really tiny. It is. I mean, you don't even want to touch it with your finger.
Yeah. Yep. There's the loop again. Got you.
Yeah. So 0.3 millimeter diameter.
So, and you are, as far as what's your process for prototyping the wheels in the watches?
So I'll first I do all of my CAD work in Fusion 360.
Okay.
Then I export the G code and then use the Bantam tool software to run the mill. I'll take one of these brass blanks, stick them on the mill. Most of the time, it's just a 2D shape. The coaxial escape wheel is actually it's 3D, so there are two levels to it. So it's two gears in one essentially.
Okay.
And the mill does a great job. It seems there's this kind of common, I think it's a misconception now, that you need a really big, really heavy, stable mill to do parts this small, but the Bantam Tools mill does a wonderful job with them. So it cuts them out. I take them out and I clean them up a little bit. I've got a couple diamond slips and stones, and I'll just clean up the parts. And then I install them in the watch. And the big thing that for installing them in the watch most of the time is I need to put them on an axle.
Okay.
So you'll notice one thing I don't have right now, which is kind of somewhat embarrassing for a watchmaker. I don't have a lathe at home. That's kind of like probably the number one tool a watchmaker has. So when I'm doing, I'm relying on axles and pinions that are in pre-existing movements. So I'm using a common movement, and I take the gear off of it, and then I put on my custom gear that I'm making, or custom wheel.
I see.
Then I use this tool, which is a Horia tool, and it's a really precise pressing tool, you could say. So it presses two parts together. It gives them a friction fit. This is a little bit of blue putty that I'll use to hold things in while I'm pressing them down. So this is a Horia tool. It's kind of a common watchmaker's tool.
Couple comments here. Someone's asking about speeds and feeds for 0.3 millimeter tools, and Mr. Schoen says that he has a Derbyshire lathe that he will sell you.
Well, thank you, Ian. I might take you up on that. I've been shopping for one. I need to get one. It's kind of just a matter of space. I don't have a lot of space for it. The speeds and feeds for a 0.3 millimeter. I run these at 16,400 RPM. I don't remember the feed rate, but it's what Bantam Tools has listed on the website.
Oh, for brass.
For brass. Oh, okay. So I started with the basic, like a basic recommendations, and I moved to the advanced. There's a separate thing for advanced, and it worked really well. Okay. One thing that to keep it, a big thing that I noticed. Originally, my spindle, I hadn't noticed it, but my spindle was getting a little bit worn out. When the spindle gets worn out, it makes a louder noise. And I was noticing that the end mills were breaking. And I think it's because there's a little bit of vibration that was being introduced.
Interesting.
So I got a new spindle. And as soon as I got the new spindle, it quieted down, and I could run the 0.3 end mills at the advanced feed and speed levels that Bantam Tools has listed on the website without any problems. So these gears, one of these escape wheels, start to finish, it's maybe 15 to 20 minutes to cut one out. So it's pretty quick. It's just tracing an outline for the most part.
Gotcha. So as you're designing these new mechanisms for the movement, what is it like? How has this changed? I guess I should ask. Like, previously before the mill, what were you doing when you were prototyping these parts?
Well, I had this idea for a while, and I was using a laser cutting service. because I knew I needed to make really small, really precise parts.
Mm-hmm.
And this laser cutting service, they do an amazing job. Very, very sharp internal corners. They can cut steel. They can cut really exotic materials with these powerful lasers. But the prices were good. But the issue for me was iteration speed. This is something it's a big deal for me. Because when I kind of get in a mode, I'm in my engineering mode, I don't want to take a week or two off between iterations. So I would get a wheel, and I'd realize I need to make a small change to this. I would make the change in CAD, I'd send it off, come back, and it was taking way too long overall. And so I realized that the Bantam Tools mill, I can iterate in less than a day, so I can make a change every day. And you could see that here. I've kind of kept a lot of the parts that are that didn't work out. So here, I'll flip the camera around again.
See the graveyard.
So this is the graveyard. Yeah, these specifically, I mean, you can tell there's just lots of wheels and levers and screws that didn't work. And each of those represents one day of machining and CAD and testing. And I had a lot of time during quarantine, during lockdown, to kind of get this right.
Do you have a pair of tweezers? Could you just hold one of these up again? Is that possible? Just for people who are just joining now, because from afar, I don't think you can appreciate the intricacies in. So cool.
That's kind of blurry here. Here you can see. I mean, you can see the size of it with my finger.
Yep.
Pretty small. So one thing that I always keep in mind when I'm milling these is the 0.3 millimeter diameter. That's kind of like the smallest point I can go to. So sometimes I got to keep thinking about that in relation to how many teeth are on a wheel, because I could only get between those teeth in increments of 0.3 millimeters.
Right.
But works out pretty well.
Okay. Someone's asking if there's a good resource for. This is cool. Eddie from last week. Eddie Stratos is asking, what's a good resource for learning to make gears?
To make gears,
I guess your response is going to be, what type of gears?
Yeah, well, that's exactly what I was thinking. To make gears for watches, the best resource, I think, is a book by the watchmaker I mentioned earlier, George Daniels. So he has an entire chapter on watch gears or watch wheels. And there's a kind of a specific tooth shape that's used in many watch gears that are not used in other types of mechanical devices or car engines. It's the tooth profile. In watches, many times we'll use what's called a cycloidal tooth profile. And in other mechanical devices, you'll use an involute tooth profile. There's drawbacks, there's advantages to each of them. The cycloidal tooth profile, it's kind of a traditional thing, and lots of watchmaking is based on tradition, so you just kind of keep it the way it's always been. But there's also an argument that the cycloidal tooth has better frictional properties compared to the involute, but it's not as strong. It's weaker. The teeth could break easier than an involute. So I would use if you're curious about watch gears, the book Watchmaking by George Daniels is a great resource. Otherwise, there are a couple. I've used these open source gear generators online, and if you just Google for gear generator, you can.
I've used that.
Yeah, you can find them, and they output SVGs, and you can import them into your CAD program. I think there are some plugins for Fusion and SolidWorks to make gears as well, but I've pretty much just used these open source SVG ones.
Yeah, the geargenerator.com is a fun site because you can also just pull down the SVG and drag that right into the Bantam software, because we support SVG milling. And then, if you're so obviously not nearly as precise. So, Nick, how big is this community that you're part of people who are saying the types of things that you are saying, are pouring over the details in the tooth profile of gears. And yeah, how many people like you are out there doing this type of work?
Well, there's a lot, specifically here in New York City. New York is could kind of be considered the center of the watch industry in the USA. Okay. There are watchmakers all over the country. There are service centers all over the country, but New York City has kind of all of the aspects of the watchmaking industry in one place. So we have major service centers from big brands. We have the fancy boutiques on Madison Avenue and Fifth Avenue. We have the auction houses. We have the journalists. So this is kind of the center where the watchmaking world in the USA is focused on. But really, watchmaking in the USA is not like it used to be. Today, we think of watchmaking, and right away you think of a Swiss watch, right? And that's because the watchmaking is really focused in Switzerland today. All the big brands are in Switzerland. They're doing amazing work. Watchmaking is a very big part of the Swiss economy, whereas in the US it's pretty small. Gotcha. So to give you an idea of the numbers, in the USA, there's around 2,700 working watchmakers in the entire country. Okay. And that number is actually decreasing. It's a tricky situation that we're trying to address in certain ways. More watchmakers retire every year than graduate from school. So that's part of my work with the Horological Society of New York, to really try and promote watchmaking as a fun, exciting career for young people to get into. It's not something that is only done in Switzerland. It's not something that is a dying art. It's fun. It's stable. It's if you're really mechanically minded, it's perfect for you. And you can work as a watchmaker here in the U.S. It's kind of like being a software engineer, where if you're a software engineer or programmer in Silicon Valley, it's really easy to get a job. They're very in demand. It pays well. It's not quite to the same extent, but it's similar. Watchmakers are in demand in the U.S. and all over the world.
What do you love about it the most?
It just never gets boring. That's what I love about it. It's the same thing I love about New York City. During the pandemic, everyone's talking about, should we leave New York? Let's move out of the city. Why live in New York City anymore? But the thing I love about New York City is that it never gets boring. There's always something to do. Apart from the quarantine time. Same thing goes for watchmaking. It never gets boring. There's always something new to learn. I'm going to be doing this the rest of my life, and I'm never going to learn it all. There's always some new thing to discover, new thing to invent. The community is worldwide. It's fantastic. It's open. It's accepting, and it's something that I don't consider it as work. It's what I love to do, and I do it from when I wake up in the morning to when I go to sleep at night. And I dream about it too. Watches are my life.
I was laughing thinking about prepping for this today to talk with you, and when we did the interview with Ian Schoen a year ago for the Bantam Tools podcast, which you were part of that same episode. At one point, Ian was showing off some new designs, and Bree, who was with me, owner of Bantam Tools, started smelling one of the watch cases, and I was like, "What is going on here?" And Ian and Bree were like, "Oh yeah, no, this is very common practice. Yes, you have to smell the watch. Is it titanium? Is it something else?" And it was just it was really fun to see the quirks of each of these communities.
Well, and I should mention my connection with Bantam Tools and with Bree. It was probably 5 years ago. 5 or 6 years ago, I was getting really into 3D printing, making these tourbillon objects, and then I was at a Horological Society of New York meeting, and it was before the meeting was about to start. Everyone was talking, and I'm like, wait, who's this guy with this huge, massive beard sitting in the crowd? I recognize him from somewhere. I'm like, that's Bree Pettis from the 3D printing world. So we got to know each other that way. We've been good friends ever since. But yeah, it's a small world.
And so we've got you're the president of the New York Horological Society, where you're really promoting watchmaking as a passion, as a career, as a hobby, promoting the history of it. And then separate from that, you have your own practice and your own work. I know some of that is sort of under wraps as you're doing research and things. What's that other, as much as you can describe it, what's that other part of your life like?
Oh, it's not really under wraps. So right now,
Cool.
my life is just it's Horological Society of New York.
Okay.
And then my own watchmaking work, which I showed you here.
Yep.
And then I write articles part-time for a website called Hodinkee.
Okay. Okay.
It's a great resource for watches and clocks and horology in general. I also had a company that I started with a friend of mine that we worked on over the past few years. And it was a company where we manufactured hairsprings for watches, which is kind of a whole nother story.
That's what I'm thinking of. Yeah, because I was looking through your feed and I saw a bunch of people in bunny suits in a lab setting, and so.
Yeah, you can see in my Instagram photos all of the bunny suit photos. We were working in a nanofabrication lab at Columbia University here in the city, manufacturing hairsprings from silicon using nanofab techniques. Hairsprings are a very tiny spring that goes into a mechanical watch, and it keeps the balance wheel oscillating back and forth. That was a company that we tried to get off the ground. The product was great. We had it tested. It worked. It was ready to go. But unfortunately, it was just really difficult to find customers for it. And so earlier this year, we shut down the company. It wasn't going to work out. But it was a incredible learning experience. Being in a bunny suit full time in the nanofab lab for years, making hairsprings from scratch. It was good because it gave me an opportunity to really learn the physics and the material engineering of what a hairspring is and what makes that work. It's a whole nother Instagram live session. I can talk for hours about hairsprings.
Let's do that in the future. I would love to do that. I mean, it's so, just hearing this stuff, it's so cool because it's like a little kid just getting lost in this other world, right? Not the like expansive universe, but this micro universe. You're talking about things that are, using 0.3 millimeter end mills and these super tiny springs, and so it's just there's something that's really pretty about this world that you get to just immerse yourself in during the day.
I appreciate it. I mean, it's the Bantam Tools mill is making it possible. I always joke about this. It's you guys officially call it the Desktop PCB Milling Machine. I think you should just drop PCB. It's a desktop mill that works great for watches as well. So I highly I tell everyone I recommend it if you're thinking about trying to make some watch parts at home, or you have a small workshop. This is a great mill for it. You don't necessarily need a huge expensive mill that like stands on the floor. This is perfectly sized for a New York City apartment. I can even put it in the closet if I need to free up space. It's small.
Cool. Thank you. Thank you for the endorsement. It's really wonderful to hear these stories about how it continues to take on a new life. This machine is roughly 7 years old, and it's gone through a couple different incarnations. But before my time with Bantam Tools, it was previously Other Machine Co. And that 7 years ago, I remember like going on Oshpark. It was is an online resource where you could order circuit boards, and at that point it was like 2 weeks. You could get a circuit board turned around in 2 weeks, and that was really fast.
That's quick.
And that's where this was such a great tool, because you could iterate a circuit board in minutes rather than waiting 2 weeks. And now China's like really caught up in that regard. And for electrical engineers who need to do 6 different designs in a day, it's still a really great resource. But for the hobbyist, it's been really interesting hearing these stories, like people like yourself, who are finding new ways to make it really effective in that same sort of prototyping environment. So
Oh yeah.
while not making printed circuit boards, making watch gears is really cool. So, can we get before we wrap? Can we get one last sweep across your desk space, just because it's so nice to see people's environment. Actually, someone before said, "I can tell Nick is a watchmaker because his desk is so tidy."
Yeah. So here it is. These are lots of end mills. These are really tiny drill bits, 0.25. These are kind of fun. I'm going to open these up. These are so small, and you can see how thin those are. I need those for some of the axles. Need a smaller hole than 0.3 millimeters.
Okay.
And this is it. Just my simple desk. And then this is my inspiration. I always have up here. This is this is the coaxial escapement from George Daniels. This is the drawing of it.
So pretty.
Yeah, and this is the South Bronx where I live. So you can see it's just tiny apartment, and the mill works perfectly for it.
Awesome. Well, Nick, where can people follow along and learn more about your work?
I think Instagram's the best place. I've been guilty of not really posting much on Instagram for a while. I've just been so focused on getting these parts together. But I'm going to try and be more active posting on Instagram. So you can follow me there. It's probably the best place.
Cool. Thank you again so much for making time. Stay safe, stay healthy, continue engineering from home, and we can't wait to see what you make next.